Dear students, in our previous video lecture, we learnt about curl of a vector point function. As a continuation of that video, here we are going to learn what is an irrotational vector. If the curl of the vector v, which is given by nebula cross v vector, is equal to 0 vector, then the vector v vector is said to be irrotational. So we already know that the curl of a vector point function v vector is given by nebula cross v vector. And if that quantity is equal to 0 vector, then the vector v is said to be irrotational. Why have we given 0 vector instead of 0 over here? The reason behind is we know that cross product gives us a vector component. For that reason, we have taken 0 vector over here, which will be 0 I vector plus 0 j vector and 0 k vector. To understand the concept that the cross product is going to be a vector quantity, we have given 0 vector over here, which is anyhow going to be 0 only. Such vector fields are said to be curl-less vector fields, or we can also say curve-free vector fields. And there is a note over here, every conservative vector field nebula phi is an irrotational vector field, since nebula of nebula phi will be equal to a 0 vector. Nebula cross nebula phi will be equal to a 0 vector. The explanation of this we will see later. As of now, we will solve problems under irrotational vector. So here we have problem 57. Show that the vector f vector, which is equal to yzi vector plus zxj vector plus xyk vector, is irrotational. So a vector point function is given over here. We have to prove that this vector is irrotational. Just now we saw that if the curl is equal to 0, that is, if curl of f vector, so curl of f vector is equal to 0, then f vector is said to be irrotational, is irrotational. So we learnt this concept just now. Using this concept, we have to prove that the curl of f vector is equal to 0 vector. So what is the curl? Curl is given by nebula cross f vector. The cross product between nebula, that is the operator, the nebula with f vector. And if this is equal to 0 vector, then we can say that f vector is irrotational. So let us prove that now. So we have to prove that nebula cross f vector is equal to 0 vector. So for that, we have to first calculate what is nebula cross f vector. So we know that by the formula of curl of a vector, it is equal to the determinant value of, first we will have I vector, j vector and k vector, and then dou by dou x, dou by dou y, and then dou by dou z. And here we will have the ith component. So this is v1, this is jth component is v2, and kth component is v3. So we have to write v1 first, so which is yz. And then here v2, what is v2? Zx. And next is v3, what is v3? Xy. So let us take and write that. If you look into the previous video lectures on the topic curl, you will understand why we have written it so. Yes, now we shall find the determinant of this matrix. So the determinant of this matrix, and here we have nebula cross f vector on the left, that is equal to, first we will take I vector multiplied with this into this minus this into this. So dou by dou y of xy. So dou by dou y of xy minus dou by dou z of zx. So this is done. And next we have j vector. So here we have j. And for that, according to the concept of determinant, it should be negative. So negative j vector multiplied with, we have to block this column and block this row. So it will be dou by dou x of xy So dou by dou x of xy minus dou by dou z of yz. So dou by dou z of yz. And then the final vector k vector, so plus k vector multiplied with, we have to block this column and block this row, so it will be dou by dou x of zx, so dou by dou x of zx minus dou by dou y of yz, so dou by dou y of yz. So we have done this. Let us simplify this now. So further this will be equal to, so nebula cross f vector will be equal to I vector multiplied with, what is the partial differentiation of this with respect to y? X will be treated as constant, for y it is 1, so you will have x minus partial differentiation of this with respect to z. So x will be treated as constant and the differentiation of z is 1, so it will be x minus j vector multiplied with partial differentiation of xy with respect to x. So on a differentiation x becomes 1, so multiplied with y, so y minus partial differentiation of this with respect to z, so y will we will have here. And then here plus k vector multiplied with partial differentiation of this with respect to x. Differentiation of x will be 1 and product we have z, so we should write z here, minus partial differentiation of y z with respect to y. So the differentiation of y is 1 and so we will be having z. So if you see, each of the components becomes 0. So I vector multiplied with 0 minus j vector multiplied with 0 and plus k vector multiplied with 0. We know that 0i vector minus 0j vector plus 0k vector is 0 vector. Therefore, we have proved that nebula cross f vector, which is the curl of f vector, is equal to 0 vector. Therefore, the vector f is said to be irrotational. So, this implies f vector is irrotational. So, hence we have shown that the given f vector, that is this vector, is irrotational. So hope you have understood this concept. We will solve one more problem to understand it more better. So here we have the next problem. Show that the given vector f vector is irrotational. So in order to prove that f vector is irrotational, we have to prove that. So to prove, curl of f vector, which is given by nebula cross f vector, is equal to 0 vector. So in order to prove that it is irrotational, we have to prove this. So to prove this, first we will calculate what is nebula cross f vector. So we know that nebula cross f vector is given by I vector, j vector and k vector. Then dou by dou x, dou by dou y and dou by dou z. And here ith component we have to write. What is that? It is sine y plus z. So sine y plus z. And here jth component. So x cos y minus z. And then we have to write the kth component, which is x minus y. Now we have to find the determinant of this value. So how do we find the determinant of this particular value? So this will be equal to, so nebula cross f vector, which is on the left, this will be equal to, first we will write I vector multiplied with, so we have to block this column, block this row, so we will have the determinant of this matrix. So dou by dou y of x minus y, so dou by dou y of x minus y minus this multiplied with this. So dou by dou z of x cos y minus z. In a similar manner, minus the second component is j. So we should take negative sign. So minus j vector multiplied with, block this column, block this row. So we will be having these two. So dou by dou x of x minus y. So dou by dou x of x minus y minus dou by dou z of this. So dou by dou z of sine y plus z. And then plus k vector multiplied with, so k vector is here, block this column, block this row, determinant of this. So dou by dou x of this. So dou by dou x of x cos y minus z, and then minus dou by dou y of, so because this into this, so dou by dou y of sine y plus z. So on further simplification, this will be equal to, so nebula cross f vector will be equal to I vector multiplied with, what is dou by dou y of x minus y? You have to partially differentiate with respect to y. So that will be minus 1 minus dou by dou z of this term, that is x cos y minus z. X cos y will be completely treated as constant, so they become 0. The differentiation of minus z is minus 1. So here already we have a minus here, so minus into minus will become plus, so plus 1. And then here you have minus j vector multiplied with the partial differentiation of this with respect to x. This will become 0, for x it is 1, and then minus the partial differentiation of this with respect to z. So sin y will become 0, for z it is 1, and then plus k vector multiplied with the partial differentiation of this with respect to x. So the partial differentiation of x is 1. For cos y it will come as it is because it will be treated as constant, which is in multiplication, and minus z will become 0. And then minus, we have here partial differentiation of this with respect to y. What is the differentiation of sin y? It will be cos y, and for z it will become 0. So negative, I will write here, it is cos y. So we see that plus 1 minus 1 gets cancelled, 1 minus 1 is 0, and similarly cos y negative cos y, so that will also become 0. So we get I vector multiplied with 0 minus j vector multiplied with 0 plus k vector multiplied with 0. This gives us nebula cross f vector to be equal to 0 vector, because this is equal to 0 vector. Therefore we have proved that, so this proves that f vector is irrotational. So we have proved that f vector is irrotational. So this is how we prove that a given vector is irrotational. I have already solved one more problem for you. You can quickly have a glance of it. So here we have problem 60. We have to prove that the following vector is a rotational. So f vector is given here. We have to prove that nebula cross f vector is 0 vector, for which I have written the determinant. Now we have to find the value of this determinant. So that will be, this is the value of the determinant. On simplifying this, we get this, that is I vector multiplied with 0 minus 0 minus j vector multiplied with 3z square minus 3z square plus k vector multiplied with this, and we observe that all the components have become 0, and so that is equal to 0 vector. Therefore nebula cross f vector is equal to 0 vector, which proves that f vector is irrotational. So I have already taught you this concept, so using that, kindly go through this problem. So in our next video, unknowns will be given in a vector, and it will be given that the vector is irrotational. Using that, we have to find the unknowns. So kindly follow the next video lecture. Thank you.